Hi everyone, I'm Shreya with USC's Young Scientists Program. And today we're going to be talking,
Here, Shreya, I have this plastic bag to help clean it up.
a plastic bag? I don't think that's going to do a very good job cleaning water up. I think I'll use this towel instead. Some materials just attract water better than other materials. Come with me to learn about some more examples.
To review from last week, a material is something that is used to make an object. For example, the material used to make a pencil is wood. We can describe them in many ways, but one specific thing that we can use to describe materials is how they interact with water. There are two fancy sounding words that scientists use to describe this: hydrophobic and hydrophilic. Hydrophobic means scared of water. Hydrophilic means loves water. So materials that are hydrophobic are scared of water, and materials that are hydrophilic love water. Now here we have some bubbles, and bubbles are made of mostly water and a little bit of soap. It's a thin film of soapy water. Obviously, bubbles pop, and they pop when either the water evaporates or dries up, or when the water gets soaked up into something else. Now let's think, which kind of materials will soak up the water? Materials that hate water, hydrophobic materials, or materials that love water, hydrophilic materials? That's what we're going to try to figure out in our experiment. For this experiment, we're going to test 4 different types of materials: a cloth t-shirt, plastic wrap, aluminum foil, and tissues. And pause here to draw this table into your notebook. This is a data table, and this is what we'll be using to make our observations. So now you're going to take your bubble solution and your first material of choice. I chose to do tissue paper first. And you want to blow bubbles really slowly onto the tissue paper. It's a little bit challenging. And when you get one on the tissue paper, you look at whether it pops immediately or whether it stays on the tissue paper for a little bit before popping. So like that one popped immediately. I did this 5 times, and then I wrote yes for all the bubbles that popped immediately and no for all the bubbles that did not pop immediately. For the tissue, all the bubbles popped right away. Then I did the same thing with the aluminum foil, and you can see right there that there's 2 bubbles that haven't popped yet. So after I did it 5 times, I put yes for all the bubbles that popped immediately and no for the bubbles that did not pop. So you saw with the foil that some bubbles did not pop. Then I did the same thing with plastic wrap. And you can see that the ones that I'm showing you here popped immediately, but there were a couple of other ones that did not. So I wrote no if they didn't and yes if they did. And last I have this t-shirt, that bubble popped immediately, so I wrote yes. And there was only 1 bubble for the t-shirt that did not pop immediately. Now that I've filled out this data table, I can count up all of the no's, so the ones that did not pop. Foil has 4, so I wrote 4. Plastic wrap has 3. Cloth has 1. Now I need to figure out which one had the most bubbles that did not pop. The one that has the biggest number, or foil, has the most bubbles that did not pop. This means that the material did not want to soak up the water that was in the bubble, so it did not pop. If the material did not want to soak up the water, that means it is hydrophobic or it is scared of water. It does not want water. So foil is the most hydrophobic material in this because it did not pop the bubbles the most. This week's scientist is Dr. Evelyn Wang. Dr. Wang is the department head of mechanical engineering at MIT. She definitely knows a lot about water, and one of her research topics is actually ultra-hydrophobicity, or materials that are super hydrophobic. Her most famous research is focused on using the sun's energy to get drinkable water from the atmosphere. That is definitely something we can all benefit from. Thank you for watching and see you next week.